Nope, time to go. It is past 8:11, we had to get started. So, we made this way too difficult for the first one. Way, way, way too difficult. What is the first thing you need to identify? The rate of change, right? Because the rate of change is going to tell us what about the function? Whether it's quadratic, exponential, or linear, right? However, I could just look at the shape and tell you what type of function it is. What type of function was it? Exponential. We should have recognized exponential right away. It had to be exponential, not even just that it's multiplying. Is that a line?
No, wait, no, not a line.
That's not a line. Is it a parabola? Nope. That's literally the definition of an exponential curve. It had to be exponential, right? It's got that flat-ish piece. It is still technically curving, but it's flat-ish, and then it starts to shoot up. That is exponential as it gets. As soon as you know it is exponential, what's the equation you should be thinking about? You got to know that equation. You've got to identify, hey, that's an exponential function. There's a times b to the x. Now, I will say part of it's my fault in the sense that I have not finished grading the understanding checks. I did not get home until 9 o'clock last night, so I didn't have time to grade them. I will get it graded today and return back to you tomorrow, so you can learn from your mistakes. But if it is exponential, that's the equation I'm using. Where a is what? By the way, Jada, do you still have that stuff to turn in? The picture that you sent me yesterday?
Yes.
Thank you. And just, I will say this because I think Jada did a great job of this. She wasn't able to be here yesterday, so she took a picture of the assignments that she was going to turn in, so I knew that she had them completed. Because if she just turned them in today, it'd be 2 days late. By showing me that she had them completed yesterday, it's only 1 day late. Right? So do that, right? When you finish them, at least send them to me and give them to me as soon as you get back. But what do I mean by A here? You got to know these things. Okay, so I want the y-intercept. And what do I mean by B? The common ratio, which even if you don't remember that term, that's my what? Rate of change, right? Which rate of change? What type? Multiplicative. You got to know those details. Common ratio, multiplicative rate of change. And that should make sense because what is an exponent? Repeated what? Multiplication. Those are the fundamentals that you have to know. Now, that y-intercept was not easy to identify. Some of us were struggling with it, yeah? What should we have done? Because y'all were staring at a graph and staring and staring and struggling. But are graphs the only mathematical representations available to us? No. What could you have made? What did you make, LaShannon? A table. That's a very quick and easy way to do this because I gave you 1 point. You shouldn't have needed it, but I went ahead and gave you 1 point. What's that 1 point I gave you? 1, 3. I need that 0, right? I can't really tell what it is, but I know 1, 3. Do I know any other points on this graph? 2, 12. So right away, we should be thinking, Lexi, what kind of rate of change do you think we might have here? Or what do you think the rate of change might be?
That's not a very good question for me.
No, it's a great question for you. You've got to think about it. Before I even put the table up there, before I wrote any numbers, what did you already know about the rate of change? Okay, that's a great place to start. What do you think we're multiplying by? You don't know what 3 times something might give me 12?
4.
Try 4, check on your calculator. You don't have to just do this in your head. Play around with it, check in a calculator. Is 3 times 4 equal to 12? So if we're keeping that prediction, it should be 3 comma what? 48. So the next point is all the way up here. Right? That's the next one that intersects on the horizontal and the vertical. Hey, what is that? Is that 48? Yeah. We now know our rate of change. We already know what B is. Oops, times 4 to the x. I still need my y-intercept. How am I going to get it? I'm going to divide. I'm multiplying by 4 going this way, so to go up, I'm going to Divide by 4, so literally it's just 3 divided by 4. It is hard to write equations from the graph sometimes. I think the slope-intercept form, or linear functions are much easier. Exponential are hard to go from the graph. Go from the table. You can make a table every single time. You just have to make sure you identify what 2 things for the exponential function. The y-intercept and the rate of change. You got to know those 2. And once you identify the rate of change within the table, if you don't have the y-intercept, isn't it pretty easy to just go backwards? Don't make it harder than it has to be. Lexi, you better with that one now? You looked kind of frustrated earlier. Or are you just tired? I feel like we're always tired in this class. What up?
We got a plotter.
Huh? You got what?
She got on
Yeah.
Did you really? You get a phone back? Oh man, it's a whole new day. That's why you're so tired. You were like texting away last night? I thought that's what it was. Yeah. I don't know how I'm as awake as I am. It might be because I've already been up for 3 hours, 3.5 hours. I don't know why I just turned the lights on. When you're awake for 3.5 hours already, it's kind of hard to be sleepy. But we all agreed what form we're looking at here? Vertex form. Ladies and gentlemen, if you have vertex form, what is the first feature you should automatically think about? You should always think about A. Let me clarify. But now, I want you to also want to be clear. Is A a feature of the graph? No. What is A telling us about? Concavity, right? So the feature I'm referring to is the concavity. But that's not even the first thing we should think about if we're thinking about vertex form.
The vertex.
H comma K is my what? The vertex. Right, again, you're saying HK, but is HK a feature? No, the H comma K, that point together, is giving me the vertex. And what's the name again? Vertex form, right? Those are things we want to attend to. We are getting pretty good at recognizing vertex form, but you got to know that detail. Now, is the concavity -2? I don't think so.
No, they're not negative.
I think A is -2, isn't it?
Yeah,
But that's not the concavity.
Yeah, no, that's just the.
Ah, it's concave down, right? A is defining the concavity. It's telling me what the concavity is, but that number is not the concavity. It's actually what we call a vertical stretch or compression. It's a reflection, that -2, but the concavity is down, right? It'd be concave down because the value of x, concave down because the value of A is negative. Yes, ma'am.
I thought it was the opposite.
What do you mean?
When you, for the A, I thought that it was the negative was supposed to be the opposite.
When was the only time that we looked at opposites?
The -4 and the -3 are the ones that, like the X and Y.
Not the x and the y.
There's just.
It was
a
it was
little bit
just-
of
so if you remember, right? It was in factored form. We had x minus r1 times x minus r2. Whoops. Right? That's my factored form. And then when I had vertex form, it was a times x minus h squared plus k. I want you to notice the only time we're looking at the opposite is here. It is always the opposite when it is x minus, because it's x minus, right? Because if I'm subtracting a positive, right, that R1 is a positive 4. But if I have x plus 4, what kind of number did I have to subtract to get plus 4? I had to subtract a negative. That is the only time it's the opposite. When it's x minus, you're looking at the opposite. So it's only that part, that factor that is with the x. Does that help clarify that? So that's a great question. Any other details up here that we want to say, yeah, that's true? So I see here 4 comma 3, 4 comma -3, and then I see the x-intercept is 4 and the y-intercept is -3. Which of those is correct? Wait, it's supposed to be -3, 4?
I was looking for that.
4, -3, so DJ's thinking this one. Any other votes? As in, no, we have no clue, or we don't want to disagree with DJ?
DJ's
It's
awesome.
usually right.
He's usually right, so we're just going to trust him.
I agree with 4 -3,
You think it's which one?
4,
4, -3? So why are you thinking that one, Jada?
because the, I don't know how to explain it, because it confuses me also. The, K part -3, it confuses me.
So, I'm just rewriting it right here. Y'all are making it more difficult than it has to be. It's x minus h squared plus k, right? So what kind of number am I adding to get a minus here?
The negative.
I have to add a negative, so k is a -3. What kind of number am I subtracting to get x minus 4? A +4. And remember, we just talked about it. When is the only time we're looking at the opposite? When it's the x component, right? Say it again. Right. Inside of those parentheses, when it's the x component, that's the only time it's the opposite. Every other time, it's exactly what it looks like.
I feel like on the Desmos things, we did them both the points like the opposite of what they were, but you know, just,
You are misremembering that. Go back and look at Desmos when you're studying for your understanding check that we have tomorrow.
We can,
Yes. So we have an understanding check on the Desmos stuff and the lesson 4 that we're wrapping up today. It's what the graphic organizer is on, it's what the homework is on. I need to see that not only you can complete it for the homework, but that you can do it on your own in class, okay? And I want to do, and please understand, like, legitimately, I call it an understanding check and not a quiz because I am checking on your understanding. And so before we get too far into the next lesson, I want to see, do we fully understand what we just learned, okay? Instead of waiting too long, because I feel like I've been doing that. Because remember, with the understanding checks, I give you feedback, right? I don't just put a score on there, I give you feedback so that you can learn from your mistakes.
It's still a grade, not what goes in later.
Yeah, it's a grade that goes in the grade book, but is that grade static, as in it won't ever change? No. There we go. Remember, the test covers the same content. So the questions on the test that go with the same content as the understanding check, I actually pull those questions, and if you improve your understanding by the test, then I reward that with a higher score. So like, learn from your mistakes on the understanding checks. I've had students, and it's not often, which is kind of sad, because I give you specific feedback so you can improve, but I have had students go from C's and D's on understanding checks to an A because of how well they did on the test. You can make a 60. If you make 100 on that part of the test, the 100 goes into place of the 60. So yes, it is a grade, but it is not a static grade. Does that make sense? We learn from our mistakes, we grow and get better. So what about this down here, the x-intercept and y-intercept? Is that true? But I mean, is 4 and negative, I mean that's what y'all said, 4 and -3. Are those x and y intercepts? They're h and k, which is the vertex. So be careful. 4 is the x value of the vertex. -3 is the y value of the vertex, but they're not intercepts. What's the only form that we saw the y-intercept in? Standard form. Our C was the y-intercept, right? What form did we see x-intercepts in? Factored form, right? R1 and R2. We got to know those details. You have to have done your graphic organizer. We need to get on that. Okay? Hey, Kyla. There is one other feature that no one thought about here, and that's why I chose vertex form. Does anyone remember any other features that we always looked at when we did the vertex form? The axis of symmetry. Remember, you can tell concavity, you can tell your vertex, and you can tell your axis of symmetry every single time when you have vertex form. By the way, I'd look at your graphic organizer and make sure you note that to yourself, right? You go to M1-73 to M1-74, there is a graphic organizer there on vertex form. You should write down, hey, I can identify the axis of symmetry. What is the axis of symmetry every single time? X equals h. Remember, it has to be a vertical line that goes through the vertex. So that x value is always equal to h. So my axis of symmetry here was x equals 4. Alright? We gotta pay attention to that. So, we got the biggest things I'm pulling away from here that we need to pay attention to. Not big, we need to pay attention to all these things. One, is the concavity a number, ever? No, it's either concave up or down. And that is based on your A, but that A value is not your concavity. We've got to remember, if it's the vertex form, we're looking at the vertex. It's the opposite of what it looks like for the X, but the K, the Y value is the same. And then we got to remember axis of symmetry there. So let's get started with today's lesson. Actually, before I get started, do we feel more comfortable with that, or do we have any questions that we need to address? Good? Going once, going twice. Sold. Alright, so our agenda today is we're going to do activity 4.2, activity 4.3, then we're going to have some questions from the homework. You could have done the homework already based on what we have covered, but I will say it is much easier once we go through 4.2 and 4.3. Probably won't get to lesson 5, but we'll try our best. With this, what we're trying to do is identify the different equations of a quadratic function. You got to know vertex form, you got to know standard form, and you got to know your factored form. And we're going to use those different equations of a quadratic function to identify the features of the function even without a graph. So the whole point, and what will be on the understanding check, is these two objectives. You've got to be able to do these two things. Okay? So yesterday, we took some time where we cut out the quadratic equations, or we wrote them down on the corresponding graphs. Remember, what did we have to pay attention to? Because we didn't write this down yesterday. What did you have to pay attention to match the equation to the graph? What was the first thing you had to do?
Figure out the form.
You had to figure out the form, right? So, identify, by the way, I think this is like M1-57 or so, 58 maybe? Okay, this is that number 3 from activity 4.1. So we had to identify the form of the quadratic function, or quadratic equation. By the way, if I ever write EQN equation, just like fxn is function, okay? So you had to identify the form of the quadratic equation, so M1-56 is what we're looking at. And I would write these notes down, because again, can you use this to help you study? Yes. Should you use this to help you study? Yes. Okay? Look at these things. So one, identify the form of the quadratic equation. You got to do that. Because what's the form going to tell you? Well, you're always going to know concave up or down, but what are you talking about when you're talking about concavity? You're talking about the what of the graph. Not just the concavity. There's some other things. Think about the objectives. Think about that second objective. What about the equation? Now, it's not really about the equation. We're using the equations to figure out what? The features of the function, right? It's not just, hey, here's the equation. We're trying to figure out the features of the function. So once we identify the form of the quadratic equation, that form is telling us about what? The features, right? The form, I don't want to say it that way, that'd be informs, no. The form tells us which features to pay attention to. Okay? The form tells us which features to pay attention to. Plainly put. The form tells us which features to pay attention to. Gotta know that. Everyone have that down? Can you wait? KJ, you still writing?
I couldn't see.
Gotcha, sorry.
It's, in 156.
So identify the form of the quadratic equation, because that form tells us which features to pay attention to. That was the whole thing you had to do yesterday. And I know we're still getting more comfortable with those features, but I will say, part of the reason why I'm also doing more frequent understanding checks, and I'm telling you ahead of time, is I need you to study, right? Like, you have to look over your notes. It's not something that magically pops into your brain after you sit in class and don't do anything for a while, or sit in class and work. It would take us way too long if I just waited till you figured it out from what we do in class. I need you to take a little bit of time to study, okay? And I've had, one of the things in the parent newsletter, or the survey that I had parents filling out, was just telling me, hey, how much time do you think your student studies in a week for my class? And the response, the longest response I got was 45 minutes to an hour. I've seen a lot of none or 30 minutes. I need y'all to hear me very clearly on this, and you may think I'm crazy, but legitimately, you should be thinking 60 minutes on the low end to 90 minutes on the upper end each week. Easy. And that's not just like study that long, that's doing homework and studying and all that stuff. But if you break that down over 7 days, what you're looking at is 10 to 15 minutes a day. That's what you need to be thinking about, 10 to 15 minutes a day to be well prepared to come in here and knock it out of the park and learn well. 10 to 15 minutes a day. And I know this is going to sound crazy, but at my high school, you were looking at, between all your classes, 3 to 4 hours a day. If you were a really good student and could knock it out really quickly, 2 to 3 hours a day. It was miserable, but I learned a lot. Trust me. ACA ain't got nothing on my school, that high school I went to.
Well,
But
no, I know ACA sucks, but I'm saying that's how homework was. It's like, it's not even stuff you could just like, learning, it was just like, here, have
just
200
work.
vocab words a night,
Yeah.
and like, you're not gonna, like, it's not
that was the thing, it wasn't, we didn't have busy work, it was definitely
Yeah.
all about learning.
Yeah, ours is
Okay, so let's move to activity 4.2. This is what we're going to do here, okay? We're going to analyze the graph, and please hear me very clearly. When you finish this A, flip the page over and there's more for you to practice on. But when you look at graph A, you need to pay attention to different features that could show up, okay? For example, when I look at F1, could F1 be this graph? That's what we want to know. Okay, so why do you say yes, LaShane?
Because it's concave down.
Okay, so right here it's concave down. And so that matches what we see in the graph, okay? Is there anything else that tells us that graph could go with that equation?
It's something negative. It's opposite of the positive.
Okay, so you're talking about here? Yeah?
Yeah.
Okay, so what do you mean by that? Well, what
Right, 'cause
feature are you noticing?
Well, because it's positive 1 and positive 4, so I'm going to be negative 1 and negative 4.
You're saying it. What do you mean by it?
Look,
Vertex.
Ooh, which one are we looking at? Are we looking at x-intercepts or vertex here?
The X
Not the x-intercept,
It's
x
X if you put it on
The X value.
Say that again, CD.
X
Because it's factor form. You can't just say, hey, it's x-intercept, or hey, it's vertex, because if you're not thinking about y, you're missing out on it, right? You're going to make mistakes when you're not thinking about the y. If we recognize its factored form, what features are we always seeing in factored form? X-intercepts. Okay? And I know some of y'all were saying good things as well, and I cut you off, and I apologize for that. Cameron said 5 words, and then I cut her off, and that's my bad. But CD is crushing on that. We're noticing that this is factored form, so I know my x-intercepts. What is the x-intercept here? Just negative 1?
Negative 1, 0.
Negative 1, comma 0. What's my x-intercept here? Negative 4, comma 0. So, yes, right? Like those features match, right? This could be the same, this function right here, because it has x-intercepts that make sense. Negative x-intercepts. right? And it's concave down. And so I might make that note of, hey, that's negative x-intercepts. It's concave down, right? And so we want to pay attention to that. Now, I will point this out. A student yesterday was really struggling with the fact that we only see this part of the graph. Is this right here ever going to quit going down? No. Is it ever going to quit going to the right as well? No. So is it going to intersect the y-axis? Yes, somewhere down here. And we don't know what that is. We don't know what the scale is, but what do we know about that y-intercept? It's what? Well, the x is 0, but what do we know about the y value? Remember, did we know exactly what these x-intercepts were?
I was thinking it's going to be negative.
There we go, right? I want us, you need to notice, all I really know is, okay, it's going to be a negative y-intercept. Right? This is showing evidence that, hey, I know these features about the graph, based on the graph, and these features match. All right, so F1 is possibility. And you need to work through these 8 different functions, identify those features, and say, hey, could this work or could it not? And so you can put a check saying, hey, yes, this is a function that matches or is it's possible. You put an X to say, no, it doesn't work, but we need to have evidence. We need something to back up our reasoning. Any questions from that? Yes, ma'am.
If you were to give us this graph with the x-intercept negative, do you want us to put the equation, is that the opposite thing you're talking about, how those are positive 1 and 4?
So I think this is answering your question. If not, let me know. So remember, it's x minus r1, so minus a negative 1. That's my r1. And so then this would be x minus negative 4. That's my r2. And so these are the x-intercepts based on the equation, and we see on the graph that they are negative x-intercepts, right? You don't do the opposite of this. We're only talking about the opposite in the equation. Is that answering your question?
So if it's already negative, we would keep it negative.
Well, remember, it's x, so here, x minus r1, is r1 positive or negative? Positive, right? So if it's x, you already have the x minus, right? So the r1 is positive. That's the whole thing, that it's kind of the opposite of what this sign is in the middle. We all good on that? Okay, any questions before we get started? No. That's not an appropriate question at this point. It's time to work on math. Alright, since there doesn't seem to be any math-related questions, go ahead and work through these 8 functions. When you are done with this page, what are you going to do? Go to the next page, right? We need to get our practice in, identifying these features so that we are ready for tomorrow.